Objective 6, know what lattice energy measures and how this relates to the physical properties of an ionic compound. So we heard the word lattice when we talked about the crystal lattice. So the lattice is the structure of the ionic compound. So lattice energy is how much energy it takes to tear that structure apart. So it's the energy needed to break an ionic compound or the crystal lattice apart again. So once it forms, what will it take to tear it back apart? And that's called the lattice energy. So guess what two factors affect that? What two factors are going to affect how much energy it takes? Size and charge, the amount of charge. Same two that we just talked about. So now smaller is going to take greater energy. And the charge on the ion, bigger charge, and again, positive or negative is going to take more energy. So then the examples I have down here, you've seen some questions like this in your problem set. Which is a stronger ionic bond, NAF or RBF? Well, if you have a periodic table nearby, fluorine is the same thing. The anion is the same for both. So fluorine's really not going to make a difference. If you've got fluorine in both compounds, it doesn't matter how big or how small fluorine is or what its charge is. So really what you have to look at is Na and Rb. And what do you see about sodium and rubidium? We've got sodium here way on the left side of period 3, but rubidium is down in period 5. So even though they're in the same family, what do you know about sodium and rubidium? Who's bigger and who's smaller? So when you find them, sodium's bigger because it's only, rubidium's bigger because it's got 5 energy levels and sodium only has 3. Which one's got the bigger charge on it? They're both in the same group. So they're both going to pick up a +1, so charge is the same form. Just like they're both bonded to fluorine, so fluorine doesn't matter. But this one, I've got rubidium is bigger, so sodium is smaller. And they have same charge. So NAF is going to be the stronger because only size is going to matter on this one if the charge is the same. Does that make sense? So then how about CaBr2 or GaBr3? Again, they're both bonded to bromine, so bromine doesn't really matter. But what do you see about Ca and Ga? How do they compare in size and charge? Which one's smaller, since smaller, stronger? You guys see them there in period 4? Ca is way to the left, Ga is way to the right, so who's smaller? Gallium, the Ga is, right? Which one's stronger? Also Ga, because it's going to have a +3. So that one, gallium, was both smaller and stronger. And then another way to ask the same question, so which has a stronger bond? Size and charge. Which one has more lattice energy? Size and charge. Which has a higher melting point? Guess what you need to know? Size and charge. So NAF and NAI Now you've got sodium for both of them. So fluorine or iodine, which one's going to make that stronger? It's going to be stronger having fluorine way up at the top or having iodine way down at the bottom. They're both in family 17, so they have the same charge. But who's smaller? Fluorine's a lot smaller. So NAF quite